Hey everyone, today I'm super excited to bring you a brand new lecture on TanStack React Router and TanStack React Query. Now I'm really excited to show you TanStack React Router because it takes a whole different view on routing inside of a React applications. Instead of treating routes as just path, TanStack React Router treats them as typed units of application behavior. A route defines its params, search state, how those values are validated, how data is loaded, and how navigation is actually allowed to happen. Or in other words, we now finally have full end-to-end type safety of our React router inside of our web apps. And so I'm going to show you how we can apply this end-to-end type safety for our routing in this basic to-do application. And I'm also going to show you how this is connected to a NestJS backend, which is actually fetching data using TanStack React Query, which is a super powerful state management, cache management, and data fetching library for the UI, which makes data fetching extremely easy. Now, finally, I'm also going to explain to you the benefits of this architecture over using NestJS. And I think you'll find that the developer experience of TanStack React Router is much better than NestJS for two major reasons. The development speed is great. We have end-to-end type safety for our routing, but most importantly, you're never going to have to worry about use client or server and client components really ever again, thanks to TanStack React Router. And I'm going to jump into all of this in this lecture. So I'm so excited to go ahead and get started and bringing you this lecture on TanStack React Router, React Query, and NestJS. Now, before we jump in, I want to give a quick shout out to my developer membership website, which I'll leave a link to below. If you sign up for my developer member website, you're going to get access to hundreds of hours of exclusive developer lectures, which are additional videos on advanced topics like multi-tenancy, gRPC, OpenTelemetry, blue-green deployments, and more. You're also going to get access to all of my best-selling Udemy courses, including my latest one on building an Instagram clone with NestJS, Next.js, and latest technologies, including Better Auth. So please go ahead and check out my developer membership website if you like this content and you'd like to get access to more. I really appreciate the support. Thank you so much for watching, and let's jump right in. All right, so to go ahead and get started with our project, I'm going to go ahead and use npm in this lecture as my package manager. And I'm going to use it to create a new Turborepo, which is going to be the monorepo manager we're going to use, which is going to be extremely helpful in this project because it's going to allow us to run both our backend and UI application in parallel, share configurations across packages, and cache builds for faster iterations. Now, I have a completely separate lecture on Turborepo, which is a deep dive. So if you'd like to check that out, I'll leave a link to it in the description. For now, I'll use npm dlx create turbo at latest to go ahead and create this. This will go ahead and prompt you for the name. I'll call this TanStack NestJS and use npm again. So this will go ahead and initialize a new Turborepo with some starting applications and packages. So applications are actual apps that we start up, and packages are shared code that we can use in these apps. So let's go ahead and cd into the directory and open it up in VS Code. And now we can see the starting Turborepo for the project. So I'm going to go ahead and start off by removing all of the applications, which are just a couple of sample Next.js apps, which we won't use, as well as the starting packages, since we won't use these in this project. And so now we have a clean slate, which is just what we want. So to get started, I'm going to go ahead and create the NestJS backend, which is going to allow us to expose an HTTP controller and offer CRUD functionality to create, read, update, and delete some tasks for our app. So for this, I'll cd into the apps directory, and you can go ahead and use the Nest CLI to generate a new app. Now, if you don't have Nest CLI, you can install it globally with npm. So at nestjs/cli at latest install global. I already have it, so I'll go ahead and run nest new, and I'll call this API. I'll use p-npm. And this will go ahead and scaffold a new NestJS application. So now that this is complete, we can see we have API inside of the apps folder. Now there's a few changes we have to make to hook this into Turborepo. Firstly, we can remove the node modules folder. And if we cd into API, make sure we remove the Git folder as well, since we already have one at the root of the Turborepo. So this should just be a fresh NestJS application. The other change I'll make is to go into the package.json and actually rename the start dev command to be dev, so that we can have a single dev task for both the UI and backend, and we can start both with this single dev command. Now this will start the NestJS development server and start up the server to listen on our default port, which in our main TS we can see is the port 3000. So this will create the starting NestJS application, bind port 3000 for HTTP traffic. And so let's go back to the root of our app, make sure we reinstall p-npm to get all of our dependencies. And now if I run the turbo dev command, you can see we've started up the NestJS development server here, which is excellent using our turbo dev task. And if I go to localhost 3000 in my browser, you can see hello world, which is the default response from a new Nest app exposed on port 3000. So our Nest app is up and running and returning traffic. This is great. So our single app module, we've declared our app controller and our app service. The app controller is exposing that one get route, injecting the app service, and this is just returning that hello world string. And so now next up, I'm going to go ahead and add the tasks CRUD functionality to our NestJS backend. Now, I'm not going to go over in this lecture the actual creation of this controller and service, since it's going to be really simple, lightweight, and I have other lectures that go into deep dive on NestJS. In this lecture, I really want to focus on TanStack on the UI side and just have a very basic NestJS server set up. So I'm going to go ahead and create this, and then we can walk through it. All right, so I've gone ahead and filled out our API backend with some additional code. And so let's take a quick walk through on these changes. Again, this isn't the focus of this particular lecture, but I still want to give you an overview as to what we've done here. So the first change we've made to the main TS is I've enabled CORS, or cross-origin resource sharing, on the UI URL that we're going to be using in this project. So what this is going to do is it's going to allow us to receive requests from different origins. In this case, localhost 3000, which will be the URL that our UI will be listening on. Whereas this API will be on localhost 3001, which the browser will see as a cross-origin resource request, and it will block this request if CORS is not enabled. So we want to enable it and explicitly whitelist the known origin that we're going to be sending requests from. Now, of course, you can also set up a proxy on your UI to avoid CORS. In our case, I'm going to keep it simple and allow CORS. So keep this set up here. And then you can see we've added a new tasks directory where we're going to keep all of our tasks related code. So in here, we just have a single tasks module with a single tasks controller and a service. So if we take a look at the controller now, let's see all of these routes that we've created. So we have a tasks controller, we've prefixed this with tasks, and we basically just have all CRUD functionality now exposed in this HTTP controller. And so we have a create route where we extract the incoming body, and we have injected the task service. So we're simply calling the task service to create, passing in the HTTP request body, which we're extracting with the body decorator. And we're doing the same pattern for the rest of the CRUD methods. So we have one to find all tasks, find one, update, and remove. Notice we're also extracting query parameters to extract the task status and a search parameter as well to search on a particular task name. Finally, our get, patch, and delete routes also are extracting a path parameter. And this is essentially just going to allow us to extract a URL path parameter, pull it off with the param decorator, and then pass it into our service method. So we have all these CRUD routes to allow our HTTP functionality. In DTO, we just have simple interfaces to create a task with a title and description. And same for update. We can update a task's title, description, or status. And finally, we have the task entity, which represents the shape of the task data. So here we have the ID, a title, description, status, and timestamp properties. And so finally, in the task service itself, we'll take a look here. In this lecture, we're just having a simple in-memory implementation, no database. And so we're going to maintain this in-memory array of tasks. So we have a few starting tasks here, where we have our tasks with some ID dummy data, so a title, description, status, and more. So we have these dummy tasks by default, and then we have these service methods to actually implement our CRUD functionality. So we have find all here that allows us to filter tasks based off of the query parameters. So here we can filter our tasks based on the status of it, or a search parameter to simply look for the task title or description matching our search parameter. And lastly, we also have methods to find a single task, create a new task, push it to our tasks array. We also can update a task, and finally remove it. So this is all really basic CRUD functionality in a NestJS app. Again, if you want to dive deeper into NestJS Backend specifically, I'll leave a link below into other lectures where we do so. In this lecture, we're really trying to focus on the TanStack UI, but now that we have a NestJS backend set up, we are ready to go ahead and start integrating our TanStack UI, which is excellent. All right, so before we jump in with TanStack UI, I want to leave a little note here as to why we even have a NestJS backend, because as you probably know, TanStack has a full stack solution called TanStack Start, which in addition to the router allows you to implement server-side rendering and server-side functions, which is very similar to NestJS server-side actions or server-side components if you've used this before. Essentially, we can execute logic on the TanStack server side. Now, the reason why I still love having a NestJS backend instead of using server-side functionality on TanStack or NestJS is really the production-grade architecture that NestJS gives us. It's this level of modules where we can declare our dependencies as injectable providers and have this dependency injection, right, where we can inject our dependencies anywhere in our application, keep them totally segregated, and we have this really clean separation of concerns between our HTTP controllers, our business logic into services, and so on. So we still have this really great NestJS backend ecosystem, and we have the best of both worlds because now I'm going to show you how we can set up TanStack UI and TanStack Query to call this NestJS backend, where we still have the great developer experience, this great NestJS backend architecture that we can use to host our business logic and more, and utilize the latest and greatest on TanStack UI. And so I just wanted to drop that quick note. For really large, complex, and production-grade applications, I still love having a NestJS dedicated backend. I don't like to keep my business logic on the UI server side, like NestJS Server Actions or TanStack Start, but that's really just a personal preference. For smaller apps, it may work okay for you. And that's really the focus of this lecture. I want to focus on showing you how we can create a TanStack UI app and connect it to a NestJS backend using TanStack Query. So let's go ahead and jump in with this next. All right, so I'm super excited to now get started with TanStack UI. Let's go ahead and set up a new application inside of our monorepo. We'll cd into apps, and now we can generate our TanStack app using npx create -ts router or TanStack router -app at latest. And so this will initialize a new TanStack application. Select yes. This will give us a file or code-based route configuration, TypeScript support, Tailwind CSS integration, toolchain setup, and more. So this is really going to go ahead and set up everything we need to get started with TanStack UI. Now here you can see we can ask what we'd like our project to be named. Well, since this is already in our monorepo, I'll just call this directory web. And let's use a file router, which is a file-based routing structure, which is really the standard and recommended way. We'll also use Tailwind CSS, and you can set up ESLint or Biome if you'd like. In our case, we can just leave without this for now. And you can also see all the really cool integrations that TanStack Router will offer you out of the box. It's kind of amazing, all of this functionality you can ship right away into your new app. So look at all these great features we can add on if we want to add this into our new project. In our case, let's just keep things simple. We want to start with a vanilla project, and I will select none for add-ons or any examples. And so let's go ahead and let the project finish initializing. All right, so now you can see our project has finished setting up. If we head back into the terminal, we can see the new web directory, and we can see the new TanStack UI application, which has been initialized. So this is great. Just as we did with the NestJS backend, let's do a little bit of cleanup to start here. Firstly, remove the package lock JSON because we're going to use pnpm inside of our monorepo to handle our dependencies, not npm. And we can remove the existing node modules as well. Make sure we also cd and remove the git directory since this is managed at the Turborepo level. And finally, let's go into the package JSON. We can see that we already have a dev script here, which is pointing the Vite dev server. And so TanStack UI uses the Vite development server as its default server, which is great because Vite is the blazing fast front-end build tool powering the next generation of web apps. It's really the fastest bundler out there to build our UI apps. And so that's another great benefit of TanStack UI. The developer experience is really next to none. Even compared to NestJS, the development speeds here are blazing fast, and you'll notice that especially in larger applications. And so this is the starting package JSON. You can see that it's been set up for us. We have all of our dependencies here, including the TanStack Router dependencies for our routing, of course, React itself, React DOM, Tailwind CSS, and some dev dependencies. Next up, we also have our scripts, right? So we have our Vite command here to start our development server on port 3000. We can build, preview, and test the application as well. And so let's go ahead and just start up the dev server out of the box so we can see things running to start. And so thanks to Turborepo, now that we've set up our dev commands in both package JSON, if we simply run turbo dev from the root, we will now run both dev servers at once. Of course, make sure we rerun pnpm install first so that we get those web dependencies installed now by pnpm. And so with the dependencies reinstalled, we'll run our turbo dev again. And now you can see both of our development servers have been started up. The NestJS backend here is listening. We can see the tasks routes being exposed here, which is great. And the web Vite server is now listening on port 3000 for traffic. So let's go ahead and open this up. If I now open up this application in my web browser at localhost 3000, we can see the web browser here with the default landing page. So this is awesome. We can also see this bubble in the bottom right, which is the TanStack developer tools. And so this is really nice. It's a out-of-the-box developer tool for TanStack Router that will actually show you the state of the current router. So this is really helpful when you're debugging. If you want to take a look at the current router tree, look at the actual state in here, see the current routes that you have. This makes it very easy to do and helps a lot with debugging as your application grows in size and you have more routes and you're trying to debug this. So this is really useful to have, and we'll take a closer look at this later as well in TanStack Query itself. But so at this point, we have both of our applications running inside of our Turborepo, and we're ready to actually start building out our tasks at UI to now leverage the tasks backend we've created with NestJS. So let's go ahead and see how we can do that. All right, so before we jump in to build the app, I want to take a quick overview of the default directory structure and just take a look at the files that have been generated so you can get a quick overview as to how the project looks. The first file is our Vite config ts, which is essentially just a configuration file for Vite, which is the underlying bundler tool we're using to build and serve our application. Now, in the past, if you've used other apps like Webpack or Next.js, you'll have a next config. This is the equivalent to that, where you can define all the functionality you want for the build and dev server. So here we're setting up a configuration with define config from Vite that allows us to extend the Vite configuration by adding additional plugins and functionality. So here we're using default plugins for TanStack out of the box, including the DevTools here, which is the DevTools bubble that we just saw that allows us to interact with our DevTools. We also have the TanStack router itself being set up here, specifying a target, as well as automatic code splitting, which is an advanced optimization feature, which is nice that they offer this out of the box. We also have a Vite React configuration and configuration for Tailwind. And so this is a really nice benefit of Vite and TanStack, is that it sort of abstracts a lot of this configuration away into simple functions that we can just call, include this, and that's all we have to do. There's no other configuration that we have to really mess with. It's all just out of the box included, which is a really nice developer experience. And then finally, we also have a path alias set up here, which just allows us to import using the @ symbol, and this will point directly at our source directory for any code that we want to import. From here, we just have a familiar tsconfig JSON to configure our TypeScript compilation options. These defaults out of the box will work great. We also have the package JSON that we just took a look at. We have a starting index HTML, which is the bootstrap of our application. This is where we define any initial loading scripts, the title of the app, and finally, this is the root div where we actually bootstrap the app. We have the important ID app div here where the JavaScript of the app actually hooks into. And then finally, we have the script where we're actually requiring our main.tsx, and that's what we'll look at next. That's the entry point to the TanStack app. Next up, you'll see we have this .cta.json file. And so this is a TanStack tooling artifact that's used by TanStack Router for code generation and analysis. So one of the major benefits of TanStack Router is a complete type safety of all of the router operations that we're going to use in the app. So whenever we navigate to routes, use query parameters or path parameters, this is all going to be completely type safe because we're actually turning our route files into typed route trees that gives us this type safety. And so we're going to take a look at this later on, but essentially all this CTA JSON does is it gives the generator of these routes additional configuration options that allows it to do that. And so we really don't have to worry about this or configure any additional options. And then finally, we have a public folder, which is where we can keep any static assets that will be deployed with the app, including any images that we can reference from the source code. And then lastly, we have the source directory itself. And so in the starting source directory, we're going to see a styles CSS file. This is our global styles sheet where we can import other styles. So in this case, we're seeing this familiar import to Tailwind CSS, which allows us to configure Tailwind, as well as any other global styles we want to apply to the app. So in this case, we have some global styles for body and code. We can keep these as is. This is fine. Next up, we have this routetree.gen.ts. And you can see here this comment, this file was automatically generated by TanStack Router. You should not make any changes in this file as it will be overridden. And this is what we were just referencing earlier. TanStack is completely type safe with its routing functionality, where it's always going to validate whenever we try to navigate to a route that that route actually exists, and any path parameters or query parameters that we supply are typed correctly. And this is one of the major advantages of using TanStack Router is this end-to-end type safety. And so this generated file here is essentially just taking the routes that we have in the routes folder. This is where we actually define the routes for our app, and we'll dive deeper into this in a second. Well, it's taking the routes that we define here and creating this generated TypeScript file where it's going to determine all of the available routes that we can go to, all the available path parameters, query parameters, and figure out the types for all of these, generate it all into this one file so that whenever we make a navigation to another page, we always have type safe operations, and that's thanks to this generated file. We then have a Web Vitals file, which allows us to report Web Vitals to Google Lighthouse and other performance tooling. So this is fine to keep. We have a logo file. And finally, we have the main.tsx, which is where we are actually bootstrapping the application. And so this is the entry point to the app that we saw inside of the index HTML, which is essentially just setting up the application. And so let's take a closer look. Here we're importing our global style sheet, and we're also creating an instance of our application router. So notice here, this is where we're providing that generated route tree file. And this is what gives this router the type safety. So we're actually providing that generated file to the router that our app will be using, giving it the type safety. We can also provide other options here. We can set context on the router, so we have global state available. And you can configure any number of options that TanStack Router offers to you. I'll leave a full list in the link below, but essentially these options allow you to configure routing functionality in your application. These defaults here are going to work great for us. You can also see here we're registering the router instance for type safety. And then finally, we are bootstrapping the application. So here we're getting that app div instance we saw in the index HTML. And what we're doing is using React DOM to create the root of our application using the root element here, that's that div. And then we're simply rendering the router provider on that root DOM node. This is what's essentially going to set up our React application by rendering the root JSX here, which is the router provider. And so this router provider is coming from TanStack React Router, and it's going to then provide it that router instance that we created up here, giving it the full type safety of all of our routes. And then of course we can access this router instance from anywhere in our React component tree to actually perform type safe routing. And that's exactly what we're going to do. And so now at this point, you have a really good understanding of the basic structure of a TanStack Router application. Let's finally jump into the routes folder next. All right, so within the side of this routes folder, this is where we define all of the pages or routes inside of the application, since we're using file-based routing. And so any new page or route you want, you'll have in this routes folder, and our route tree.gen file will automatically regenerate based off of its structure. And so in here we have the starting root.tsx, which is the entry point to our router. And you can think of this as essentially the root layout.tsx for a NestJS application. It's essentially the root route that will render no matter where we are in the application, which makes it a great place to put any global code. And that's exactly what we do here. The first thing is render the outlet. And so the outlet for TanStack Router is where we essentially render the current route that we're on. So this will be the current route or page we're on. And we have any other global code we want to render here. So in this case, we have the TanStack dev tools that we saw earlier. And we could actually configure the position of it, which is pretty cool. And we have a TanStack Router plugin. And so this is all being fed into this create root route function from TanStack React Router, which takes in the root component that you render. And of course, this is what gets rendered in the main TSX through the router provider. So this root component will always be rendered no matter where you are. And then thanks to the outlet, that's going to render the actual page we're on. And so by default, we have a single page, the starting root index.tsx, or the home page. And this is exactly where we saw here on the home page of the app. And the reason why we can see this is because unlike NestJS, TanStack Router is very declarative in its routes, where the first thing we do is define the route const at the top of the file here and set it equal to this function, create file route. So create file route is what we call to create a new route in the application. We don't just create a new component inside of here. We have to call create file route and then pass the actual path on the web app where this route will be rendered under. So here, since we're passing a slash, this represents the root of the web app or the home page. And so that's where we're going to render this app. And then now with inside of create file route, we specify simply the component that we're going to render on this page. As simple as that. Now there's a number of additional parameters you can render here on the create file route, including the ability to server-side render, preload data, and more. These are all advanced topics that I might go into in future lectures. In this lecture, I really want to stick onto just the basics of TanStack Router so you can get up and running with your app, and also show you how you can integrate TanStack Query to directly reach out to a backend like NestJS. And so for us, this default configuration for the route is just what we want. And so here we're defining the app component, and this is a simple React component. It's just basic JSX that we now provide, and that means whenever we go to this route, we're going to render this JSX. And so it's as simple as that. I think it's a very nice declarative way to define our routes because we keep the route definition and the component in the same file. It's really nice and clean to me. And notice another amazing benefit to using TanStack Router and TanStack Start over NestJS is you're never ever going to have to think about writing use client anymore, right? Notice we don't have to have any use client directive in here. There's no need for it anymore because TanStack Router doesn't use server components at all. TanStack Router is client focused, not server focused. In my opinion, it's a much better developer experience. You're not going to have to think about client or server components or run into any annoying errors about this anymore. We're just going to focus on writing JSX and our components, okay? Everything is client focused. Now, you might be concerned about the performance implications of this. And like I said before, there are ways to actually still preload this JSX on the TanStack server side using TanStack loader functions, which run before rendering. They can run on the client or the server, but they're not components. They're separate server-side functions. And I want to make that point very clear, is if you're just using TanStack Router as a client-facing application, which I think is a great move for most apps, and you just want to call a already existing backend using a tool like TanStack Query, which is exactly what we're going to learn in this lecture, then you don't have to worry about any of this. We can just focus on our client-facing code. TanStack Router will still be very performant, very fast. The developer experience is amazing, and we're going to see how we can reach out to our backend directly with TanStack Query. So I just wanted to drop this note because I think this is a great benefit, is not having to worry about these server components and marking every component as use client, which I just think is really obnoxious in the NestJS world. Now everything is client focused and is a great developer experience. All right, so now at this point, we've gone over the routing structure of the routes folder. I hope you have a good basic understanding of the starting TanStack Router application where we define our routes in this routes folder. We have this create file route function to define new routes, and we have this simple component property syntax. And so if you're just learning this for the first time, I know this might seem like a lot, but trust me, it's a very nice developer experience. And as we build out this app, you'll pick it up in no time. So next, now that you have a good basic understanding of the starting structure, we can start to build out our actual task app. So let's go ahead and do this next by creating a new route for our tasks page and start setting up our data fetching functionality using TanStack Query. All right, so the first change I've made to our application is I've modified our root index.tsx homepage with my own JSX instead of the default boilerplate. So we still have the existing route object here where we're calling create file route with the root path and the homepage component. Nothing's changed here. It's just the JSX itself that I've now updated. Now, I didn't want to spend too much time in this lecture going over all of the JSX and Tailwind styling for each component because you can feel free to customize this any way you want. I've just used Tailwind CSS, which is already included in our application, to apply some basic class styling to our divs here to give some nice look and feel to the home page. So we have some basic title and text and some feature cards, which is a separate component inside of this same component that I've created, which is just outputting some basic text. Really nothing has changed too drastically. But the important bit that I want to show you that I've added here is you can see I've actually introduced a new link. So in TanStack Router, in order to actually link to other pages, just like in NestJS you'd expect, we have a link component, a dedicated link component from TanStack React Router. And we use it in a very similar way to how you'd expect a link component to work. You have the to prop and you specify the path as to where you're going to route the user to when they click on the link. We also have some dedicated class styling on it. But here is the real power of TanStack React Router that I want to show you. You can see the to prop here is actually complaining because it doesn't detect this task's route actually existing in our application. You can see the only types that the application knows about now is the single root homepage component. And this is the beauty of TanStack React Router. It's this type safety of the router itself. In any other application, we could provide any route here, and it wouldn't be until runtime that we'd experience this issue of a 404 because this route does not exist yet. But since we have auto-generated our routes and we have this type safety, we know at build time that we have this issue with the router. And this is really the magic of TanStack React Router. And so what I'm now going to do is I'm going to create a new tasks page to remedy this. So to do this, inside of routes, we'll create a new folder called tasks where we'll keep our tasks routes. And so now in the tasks directory, let's create a new index.tsx file. And look how cool this is. If I actually create an index.tsx in tasks, it will actually auto-generate this code for me right inside of this file with the tasks route already defined without me having to do anything, which is just super cool to me. I love this. So the code here we can see is just as we saw on the home page. We're calling a route const with create file route, and we're passing in the path where we want this to be rendered under. In this case, that'll be /tasks, and then simply pass in the component. So here we have the default name of route component. Let's make this a bit more, let's improve this name. We'll call this the tasks page and rename the component tasks page. And so now we have the starting route for the tasks page here. So you can see how quick and easy it is to create a new route with this auto-generated code. So cool. And now importantly, notice that the type error is now gone inside of our home page because this route now exists. Our route tree.gen automatically regenerated with our new tasks route here because of course our development server is still running in the background. It updated when we made a change, regenerated the router, and now our code is working. So that's awesome to see. So now if we head back to our home page, you can see the nice looking homepage demo that I've set up here with some basic starting text, the feature tiles, and the button to now navigate to the tasks page. So if we click on here, we can see the expected navigation. Of course, this is a single page app navigation event. Of course, there's no reload of the browser. This is just navigating and preserving our application history. And we can see the starting JSX on the page. So this is awesome to see. All right, so now at this point, we're actually ready to start integrating TanStack Query, which is the client-side query library that TanStack provides, which is a powerful client-side library from TanStack that provides full state management, data fetching, caching, optimistic updates, and really any sort of operation you'd expect to need for your client-side data or state handling, you will have access to through TanStack Query. It's a really nice experience, especially combined with TanStack Router. And so let's see how we can integrate it. So the first step is to make sure that we have the dependencies we need. So let's cd back into apps web and npm install at TanStack/React Query. So this is all that we need for React Query. And now let's go ahead and firstly restart our development server. And let's go ahead and set up the TanStack Query. So to do this, we're going to head back to our root component, which is the best place to do this because this is the root of the app which will be rendered on every single page. And so in here, we can firstly create our query client object, which is going to be new query client from TanStack React Query. And in here, you can configure a lot of options for the query client. And so I'll leave a link below where you can access all of the options. I'll show you some default ones for the queries themselves. So a big benefit of TanStack React Query is that it caches our data. so that when we leave a route and, for example, then come back to that same route, well, we won't by default re-execute the same queries for that page or component if the data or input for those queries didn't change. So it makes navigating around our app really fast because we only have to load the data once, and then that data can be reused and shared amongst every single component in the application that uses this query client without having to refetch back to the server. And so that's really convenient. However, there's other options we can set on this cache depending on your application's needs. So you can set a property called stale time, which will actually automatically refetch all of your queries at the interval that you select here. So in this case, this is a 1 minute stale time, which means after 1 minute, our queries will automatically refetch to the server and get the latest data. So depending on your use case or your queries, this can be really useful if you need to have fresh data every so often. So this is essentially implementing polling for us out of the box. You can also define a refetch on window focus function and a lot of refetch parameters here, which essentially controls when React Query will refetch data. Now by default, React Query will fetch data whenever a user returns back to the screen to fetch the latest data. However, you can configure to not do this by setting this property. And like I said, there's many more options you can set and configure on the query client here. And so I'll leave these default options for now. Now to actually provide the query client to the rest of the app, we're going to go ahead and use a provider to do that. So we can go ahead and use the query client provider from TanStack React Query. And this is going to be a React provider using Context API, where we can provide the client object, which is simply the query client we just created. And now, thanks to the outlet being rendered underneath this provider, any single component inside of our tree will have access to the query client through hooks, which is excellent. And so this is really all that we have to do to get up and running with TanStack React Query, which is really nice. Now that we have TanStack React Query set up, the next thing I'm going to do is define all of the APIs on our client that we're then going to call on the NestJS Backend. Now, if you recall, in our NestJS Backend, we set up our tasks controller here to expose all of our CRUD routes. So we have all of our CRUD functionality in these HTTP methods. Now what I want to do is create a corresponding client-side file that will have all of the functions needed to call these routes, and then we can feed these in to TanStack React Query to actually make the fetch calls directly from the client side. So to do this inside of our web folder, at the root, let's create a new lib directory, and I'll create a new API.ts file. Now in here, we're going to go ahead and do a few things. The first is I want to define API URL, which is the location of our backend endpoint. And just like any application, it's best practice to encapsulate this into a .m file that we can read in, because this will change depending on where our app is running. Now Vite has first-class support for environment variables. All we have to do is prefix the environment variable in a new .m file at the root called .env, and make sure we prefix each environment variable with Vite, and we can call this one API URL, and we'll point it at HTTP localhost 3001, which is where we know our NestJS server is listening. And now to pull this off, we call import.meta.env and use the Vite API URL that we just defined. So now we have the API URL, which is great. I also want to create in lib a new types.ts file, which is just going to be the types that we've already set up on our NestJS backend. Now this being a Turborepo, typically I'd keep these shared types in a Turborepo package, which allows us to share them amongst multiple apps so we have a single source of truth. And if you're interested in this, I'll leave a link below to other videos where we've gone over this pattern. But since I want to keep things simple here and still have some form of type safety, I'm just going to duplicate the types that we've already defined on the backend. So we have a type here now for the task and a task status, which is the status of the task. All right, so this is looking good. Now in API.ts, let's go ahead and make sure we import the type for the task that we just set up. And now what I'm going to do is copy over all of the data fetching code that we need for our API. And like I said before, I don't want to spend too much time on this generic boilerplate API fetching code because it's pretty straightforward. And of course, you can reference the GitHub repository to see all of it. So let's take a quick look here as to what we're actually doing. So we're simply defining an API object with the tasks property. And in here, we just simply have all of the API endpoints that we know we've set up and created a separate function for each one for all the CRUD functionality. So we have list, get, create, update, and delete. And so within each one of these, we're taking in optional parameters. So for example, for list, remember we can take in those query params, which target the status or search parameter. And so in this case, we're constructing some new URL search parameters, checking to see if they're passed in as arguments to the function. If they are, we're setting the search parameters, creating a query string, and then finally just using fetch, the normal client-side fetch API that we all know and love. We're just using this to call our NestJS backend directly. So we're providing the API URL, which is our NestJS backend, at /tasks, which is the prefix that we assign to the tasks controller. And in this case, we're providing the query parameters that we're then extracting from the NestJS backend. And it's as simple as that. We're just performing this fetch, checking to see if it's okay, and then parsing the response as JSON. And that's what each of these methods is doing. So for example, for get, here we have the ID of the task we're trying to fetch. Well, in this case, we're just passing that in as a path parameter. And that'll correspond, we know, of course, to our tasks controller, get, where we're extracting the path parameter, passing it into the task service. And so we have one of these for each of our CRUD functions. So one to create, which is a post method now. Make sure we set our application JSON header and stringify the data as a body. And same thing for update. We have a partial of a task that we can take in as the data update. And finally delete, which is an HTTP delete method. So this is all basic boilerplate fetch code to actually reach out to our backend. But now with this in place, we can now set up our TanStack queries. And so for this, in the lib folder, I'll go ahead and create a new queries.ts file and then paste in all of our query code. And let's take some time to walk over all of this code. All right, so let's go ahead and walk over all of this code. For now, let's ignore the task keys because this is probably the most complex part about TanStack query. Let's go ahead and dive into the queries themselves and start with some simpler ones. So first, let's look at the use task query. So this is a query function, or essentially a hook, because use query here is what we're calling. And so use query, we're importing this from TanStack React query. So use query is a hook that we can call and pass in the data we want and pass in the parameters to fetch the data. Now use query is very simple. It's a object configuration we pass in with two important properties. The first one is as simple as it gets. It's the query function, right? It's the function that actually will reach out to the server and fetch the data. Well, we already just set this up inside of the API file. So here we're calling into our API object, which we're importing from API, and we are reaching out to tasks property and calling that list function. So remember, if we look inside of list here, all this is doing is taking in these search parameters, adding it to the URL, and we're calling fetch with these search parameters serialized. So this is the actual function that triggers the fetch call and reaches out to the backend server. That's really all we need to know about query function, probably the most important part about this. Now the second part to use query, and this can take a little bit of time to digest, is the query key. Now, the query key for a query is essentially an identifier to identify this query inside of our cache. So whatever query key that we supply for this query here as the query key property is the same query key that we then use later on when we want to essentially bust this cache. So in this case, you can see for query key, we're providing task keys.list method and passing in our filters. Now, the reason why we're doing this is because we want this query to be cached based off of the filters that are passed in. Or in other words, we want a separate bucket for cache for each query we make for different filters because, of course, if the filters are the same for the query we're making, we can reuse the existing cache. And that's all we're trying to do here is identify a cache key that stays the same based off of the filters that get passed in. If they are the same, then we can reuse this query cache, or in our case later on, clear out this cache based off of the query key. The way we've implemented this is creating a centralized object here called task keys, which provides a query key for each of our operations based off of the operation details. So in this case, for use tasks query, well, we called list to get all of the tasks based off the search parameters, so we know the filters are really what determines the cached value. So under task keys, we have this list function that takes in the filters, and then we have an array value. So in TanStack React Query, all of the cache keys are arrays, and these arrays are hierarchical. And so what do I mean by that? Well, let's take a look at list, for example, and see what this array actually looks like in reality, right? So if we take a look at this, you see here, we're spreading task keys.lists. Well, lists here is another task key where we're spreading task keys.all. Well, .all is simply a hard-coded string, tasks. So this represents all tasks in our application. Next up, we have list itself. So we have list as part of lists because we're copying over everything from lists, which includes task keys.all and list. And then finally, we have the filters themselves. So in our case, that would look something like status equal to whatever, some dummy string, and search equal to some dummy string, for example. And so this is what our query key looks like in an example for this use task query function. And so what do we mean by this query cache being hierarchical? Well, we mean this. If we then trigger an optimistic update later on to invalidate the cache by, for example, passing the query key of tasks, that means any single query key that contains tasks in its cache array will be cleared. So for example, in this case, since useTasks query has tasks, meaning every task, the cache will be cleared. Same thing for lists. We can get more specific. Instead of clearing all tasks, we just want to clear any list queries. So if we use the list identifier, that will target both list here and lists since it contains list. And finally, the most specific we have here is the filter itself. So if we clear cache or revalidate based off of the object here with these exact properties, that will target any query cache we have with this object in it. Now, this is your first time learning TanStack React Query and this caching mechanism. Believe me, I know it can be really confusing at first. I urge you to rewatch this explanation a few times, play around with it, read the docs, and it will become more clear over time. Essentially, you just need to keep in mind that the query key here is always an array. These values can be anything we want. They're essentially just identifiers for later on when we want to clear or invalidate this cache. And by making it as specific as possible, we can ensure that we are only removing or updating cache that's specific to the operation we want. So in this case, notice for use tasks query, we're passing in the filters so that we will clear any cache based off of these filters, or if we clear any list queries or tasks later on. And so as we progress down, we'll see the same thing. For use task query, we're using the get function for the query function. And the query key is calling .detail now, which is going to be all of the task keys .detail, which is task keys .all, detail string, as well as the raw ID for the task. So later on, remember, if we invalidate a task by its ID, that will include this detail query cache because we just supplied it. So these are our queries. And so this query, remember, is going to be reused in any component in our application that wants to get access to this query, this data, and it's going to reuse the same query cache. So the first time we call this, we'll call the query function. And then from then on, if the parameters here are the same, we won't re-execute and make duplicate network requests. We'll just use the existing cache, and we can clear it by the query key. All right, so now let's take a look at our mutations. So for the mutations, the first thing we're doing here, for example, to create a new task, is to get access to our raw query client object. Now remember, since we set this up as global context inside of our root component as the query client provider, we can access this query client object anywhere in our application using this hook, use query client hook from TanStack React Query, and this will give us access to the raw query client object, and this will be important in a second. Now for mutations, instead of use query, we call use mutation to represent a data update. And here we have two properties we need to define. The first is the raw mutation function, which is very similar to query function. This is going to be the actual underlying fetch call we make to actually perform the operation on the server. So in this case, we're just calling create from our raw tasks object. And here we're making that fetch call to the server. And importantly, we pass in data here. So data, we can define the type, and this will be type safe when we use it in the component. So we have the data we need to perform this create mutation. And then next up, we have an onSuccess callback, which allows us to do something after this mutation has succeeded. Now in our case, after the mutation has succeeded, well, we know we need to update our local client cache. And there's two ways to do this in TanStack React Query. The first way is much simpler, and for smaller low volume apps, I think is a really smart way to do it. You just invalidate the query and refetch the data from the server. We don't have to worry about complex optimistic updates and updating cache directly in memory. Instead, we just tell the query client to invalidate the existing query. And how do we do this? Well, remember, we just learned that queries are invalidated by their query key. So I hope this is where this finally comes full circle. This query key makes more sense. Well, to tell TanStack Query which query we're actually invalidating and telling it to re-trigger the query and fetch from the server again, we provide the query key. And so, well, in this case, we want to refetch any query cache in our application that is using the lists query cache. Because in our case, this is only going to be the queries that are showing all of the tasks. Because in our case, we only have one place where we're using this in the query cache list, and that's where we want to refetch. So here we could provide any number of query cache to invalidate based off of where it's used in our app. So if we wanted to be even more aggressive, we could set this to all, for example, by setting this to task keys.all, and that would invalidate all of our cache thanks to the way we've built this. Or we can keep it as is and just say only query cache that is using lists. Well, in our case, if we look, we can see we're using list as the query key for our use tasks query. So that will cause this query here to be revalidated and refetched. I also want to show you how we can provide an optimistic update. So in this update task mutation, we're calling use mutation again, and we're calling our update function for the mutation function. But now in onSuccess, instead of invalidating the query itself, the query level, we are actually updating the cache in memory without refetching the data from the server. And to do this, well, onSuccess gets the updated value that returns from the mutation function as a parameter. And then you can use this to update the query cache. So here we use the query client.setQueryData function. And this function works similar to invalidate query, where we need to provide the first parameter as the actual query key that we're updating. So in this case, since it's a single task that we've updated, we can use the taskkeys.detail function, which takes in the ID of the task and returns the query cache array with the ID inside of it. And so this correctly identifies the query cache for this singular useTask query, because when we fetch a single task, we're using the query key, the same one here, taskkeys.detail, passing in the ID. And so in the mutation update now, we're just passing the same thing, so we target that same cache value. And then the second parameter is simply the task that you want to update. Here we also invalidate the query to refetch the list itself. And also I want to show you we can remove queries directly from the cache. So in this case, for delete task mutation, in the onSuccess, we are actually calling remove queries now. Directly delete an entry from the cache. Again, you need to provide the query key. So in this case, we're providing the detail function, which will return us back the query cache for this specific task that we're removing. So this is a quick overview of TanStack React Query, its caching mechanism, and how we can set this up. Again, if this is your first time encountering this, I know it can seem like a lot, but once you have these queries and hooks set up, it's really a breeze, because now we can use these anywhere in our application and have a consistent uniform interface for querying and mutating our data, have that cache built in, and have our data up to date, which is excellent. All right, so it's finally time to tie all of this together by creating and filling out our tasks page. So I'm going to go back to our tasks index.tsx and paste in the completed JSX for this task page. Now, importantly, make sure we've actually moved our lib folder directly inside of source directory. So now let's go ahead and walk over this TanStack code so we can get a sense as to what's happening. So the first thing you can see is we've defined a new type for task search. So this tasks page is going to utilize our query parameters in the URL. We're going to have a status query parameter and a search, which, as you remember, corresponds to our tasks controller. We have these two query parameters that can get passed into task find all. So these correspond to the same query parameters here that we're taking in the component. And so importantly, we define a type here to actually represent the shape of what these query parameters should look like in terms of their type. So here for search, we just set it as a string, and status, well, this is going to be equal to the task status type from our task. So one of these three task values will have to be set. And so why are we doing this? Well, let's take a closer look at our route configuration now, because here you can see, in addition to component, we now have this new validate search property. And so what is this doing is it's allowing us to actually perform runtime validation on our search parameters that are passed into this page. In this case, we provide to validate search. Well, the first argument is the raw search query parameters that the URL receives. And then the return type is an object where we define the expected properties that the query parameters should be providing us. So in this case, search and status. Now here we actually define the type, or cast it to the expected type that we want. So in this case, a string and task status. And then we say, or a default value. So in this case, if status is not defined, then we default it to all. And if search is not defined, then it's an empty string. And so this is extremely useful, because not only do we have this validation of our actual types of the query parameters, which is going to make sure that when we navigate to this route, that these values are provided. Well, in this case, they're optional, so they won't be enforced, but we have defaults for them if they aren't provided out of the box. And if they are provided, we make sure the types are correct, thanks to this type safety. And we can see this in real time if we go back to the tasks page now, which we can see is looking very nice. Well, look in our URL, we have the status and search parameters predefined. If I try removing the status search parameter now and enter the URL, notice that it's automatically been repopulated. And this is thanks to this validation that we now have and this defaulting logic. So again, another great benefit to TanStack Router is this type safety of the routes themselves, but also the parameters here. And again, this is all thanks to the route generation logic. All right, so let's go ahead and dive a little bit deeper into the other parts of this component. So the first thing we're doing here in tasks page is using this route.useSearch hook. Well, we're actually using the route const that we declared up above, and we can see it exposes this useSearch hook. And all this is doing is it's providing us the query parameters here that have been validated and defaulted based off of the logic we specified. So if we look at the type for each one, we know it's task status or undefined, and same thing for search, string or undefined. So this is awesome. We now have type safety of these parameters themselves. Now we're also creating a const navigate here and calling use navigate. So use navigate is how we can programmatically navigate inside of our TanStack Router app. So this is a hook that you'd expect similar to use route from Next Navigation. This allows us to navigate programmatically, and we provide this from property, which is the existing route.full path. And so all this from here is doing is telling the router that any navigation from this should be based off of the path here as the relative route. And so in this case, we're doing this because we're going to navigate to the existing route we're already on with some updated search parameters using our search functionality. So then from here, we also have some state, some basic state, and then importantly, we have our query that we set up earlier, the use tasks query. So remember, this is coming directly from our queries file, the use tasks query, where we return our use query function. Now, this is a hook, remember, where we pass in our filters. So we're passing in the filters here, status and search as parameters, and we can see the properties that we get returned back. So in this case, we get the raw data returned back that we're renaming to tasks, which is the underlying tasks. But we also get helper properties like is loading, is pending for different loading states, so we can show loading indicators, or an error if any errors occur during this fetch call inside of the query function. If any errors here bubble up, they will be populated on this error property for easy error handling. Here we have a simple const for some status colors. And then next up we have search functions to actually search on our search bar for our tasks. And this is key. Here we're using the navigate function that we set up earlier to call it as a function. And we're using the search function on here to append additional search parameters onto the URL. So in this case, search, to add search parameters, well, it's a function that gets passed in the existing search parameters as previous. So what we're doing is we're returning a new object, which will be the new search parameters. So we're spreading the existing ones and then overriding, in this case, this status to whatever new status is passed into the search bar. And what's really nice about this is we have the type safety. Because we know this status search parameter should be a task status that we set earlier. If, for example, I changed this new status to be just a string value, notice that TypeScript complains here because this status value might not be one of the accepted statuses that we set up on the type. And so here is the type safety from TanStack React Router in action. Since this is a task status, it's being validated as such, which is awesome. And we can see the same thing for handle search. And so what this means is if I try to now enter in a new search query, for example, look for the build task, you can see the search parameter up here in the URL gets updated, and we can see the updated task being reflected since we are refetching this data as the URL changes. So this is great. You can even see in my network tab here, I'm making a new request with the updated search parameter, which our NestJS server is extracting and returning from the array thanks to our business logic there. Now we also have some helper components to render out a loading state based off of the loading indicator, and same thing for the error. These are simple JSX components that we're rendering here for any error or loading states. So I just want to show you how easy this is with TanStack React Query. And then finally, we have the raw JSX, where we are actually rendering out all of our component JSX. Now here I want to show you where we're actually rendering out the tasks. So for here, we're iterating over the tasks that are returned back from the query. And for each one, we are wrapping it inside of a TanStack link, just as we did before. And notice, thanks to our type safety, this route that we're trying to navigate to and even the params we're trying to provide, these don't exist yet. So we're seeing an error here as expected, which is excellent. So once we set up this new page, these should go away. So we're rendering out the task details. And then finally, we have a create task modal, which is a modal component that I created here to create new tasks. Now the create task modal is also using the create task mutation. So in this case, we just get access to the create mutation function, and then to call it, we call the .mutate function on it, where we pass in the parameters. So in this case, we have the input data that it expects, the variables, which is the title and description, which if you remember is coming directly from our use create task mutation. And here the mutation function expects this data. So this is a type safe operation. If these types differ, for example, if I change the title to be a number now, that will not fly in this type safe world we now live in. So that's awesome. And as a second parameter, we also have an options object where we can have an onSuccess callback to mutate. So after this completes, for example, we close our modal out. And so this is some basic JSX to support task creation. Let's go ahead and test it out. If I create a new task, test, create it, you can see if I remove my search parameter, we have the new task populating. And so what this is showing is that our cache invalidation is working properly, because look here, if I create a new task and create it, as soon as we create it, notice we are refetching the latest tasks from our server, and this is thanks to the mutation query key that we set up, where we are invalidating that cache and telling TanStack React Query to refetch this after we complete it. So we always have the latest data from the server, which is excellent. Now, of course, the last thing we need to implement is the task detail page itself. So let's go ahead and do this now. All right, so lastly, for the individual task page, let's go ahead and inside of our tasks folder, for a single page, we're going to use the $task.id.tsx, and we'll see why we do this in a second. You can see our auto-generated JSX, which I just love to see. And I'm going to paste in the working code for this task component. So the first thing we want to show is that we have the route here with create file route, as we'd expect, with the new component being defined. But importantly, notice here on the file route that we've now supplied tasks and then task ID variable with this $ syntax that we're extracting. And so what this does is it tells TanStack React Router this is a path parameter. So now when we go back to the tasks page, for example, and go down to the link, well, firstly, the 2 is no longer erroring because this is a valid route based off of the route configuration we have. But also it now expects this path parameter. If I were to take off the params here, we can see link is throwing an error because it expects params, which is really great to see. So now if we add this back on, it knows that task ID is the variable we need because we have just templated this out here with a $. So when we click on a task now, we are brought to the individual task component. From here, we can go ahead and update our status on it. We can update the actual details, and notice our query cache is updated in real time thanks to our optimistic updates. So now if I go back to the full tasks, we can see it reflected here. And I could even delete it as well, showing our full end-to-end working as expected. Now, there's not a whole lot that we need to look at in this individual task ID page. The first thing I'll show you is that we are able to extract the route parameter using use params on the route itself. and this will extract the type-safe task ID, which then we can then use to fetch the task using our useTask query, which takes in the task ID. So we get the task from the server, we get access to our mutations to update and delete, and then finally we have our actual functions to trigger the mutations. So in this case, we have update mutation.mutate to handle the mutate with the updated data. Same thing for delete, at which point we're also navigating back tasks listing. We have some error and loading state, and finally we have the JSX for this actual component. So again, I wanted to save you some time in going over this JSX. You can feel free to dive deeper, play around with this, which I highly encourage you to do to get familiar with this. But really, I wanted to show you at a high level the real large benefits to using TanStack React Router, which really at the end of the day is this really nice developer experience of creating new components, not having to worry about use client, use server, any of that nonsense. And most importantly, we have the type safety of our router. Thanks to the auto-generated router tree, we now have type safety of the routes, path parameters, and query parameters. So I hope you learned so much in this lecture. Thank you so much for watching. If you'd like to see more TanStack Router or TanStack Start in the future, please do let me know, or any other lectures that you'd like to see, please drop a comment. Thank you so much for watching, and I'll see you in the next one.